Now, let's explore multiplication on the Pythabacus, where the first factor is greater than the base. So first, I'll reset the beads. Against the right post. Then I will define the elements by the numeral 1. So I'm going to start adding elements. 1, 2, 3, 8. But now I want the factor to be greater than the base. We'll let the base be 8 again. So I will go back to the first bead and add 5. And so I will push those beads over to the left post. Now, if I want to continue, I now have changed my defining numeral to 2, and I can continue, say I continue with 2. And push those out. So that shows me now that I have 2 inner products from my multiple of the base, so I get 2 times 8. 2 times 8 is 16. So I would count these 2 beads by 8 to get the 16. And I have 2 times 5 to get my outer product, this group times this group. And I get 10. So it says my answer to 13 times 2 is equal to 16 plus 10, which is 26. Now, I could continue pushing this last bead over. And now I have 13 times 3. And so my outer product is going to be 3 times 5, which is 15. 3 times 5, which is this group, 3 times this group, these groups, 5. This extension of groups times this extension of groups. To get my outer product, 3 times 5 is 15. My inner products, we can see, are here. They are the inner products because these are the groups that have distinguished elements. These elements are not distinguished, so we can't have any inner product. So the inner product here is going to be 3, and so I have 3 times 8, which equals 24, and 24 plus 15 indeed equals 39. Now, I could continue by pushing the rectangle over to the left post. and continue with the second count over here against the left post. Since I can't continue any farther this way because I'm using base 8, I can't count above the base. But I can go over here and add to my second count of 2s. So let's say I go 2, 3. And then I push the 4th bead over. And now we can see that my outer product is going to be 2 times 3, which makes 6, which we can see down here. I have 2 and 3. I have an extension of 2 groups, an extension of 3 groups. So 2 times 3 will give me my outer product of 6. Now I have to get my inner product to get my multiple of the base. And here I have 2 times 1 distinguishable elements. So that inner product is 2. And the inner product is 2 for each one of these. Then I have the inner product over here where I have single differentiated elements, so that's 1 times 1. So I have 1, 2, 3, plus 6 is 9, so I have 9 times 8, which we can see gives the inner product of 72. And so plus 6 gives me 78. And we can see that indeed 6 times 3 is 18. Carry a 1 will give you 78. And so you've seen in that way you can multiply with your first count greater than the base, as was the case for the elements defined by the number 1. My first count was greater than the base, which was 8. And then I demonstrated my second count is 6.